All right, so last day, I think everybody probably got an email saying that I made a small update to the program yesterday, which was basically just in the form of, I think I moved some of the stuff that was in kind of the, if name equals main part, I just moved that to a function. And today we're going to see why it's a good idea to try and keep stuff in functions and try and keep stuff atomic and that sort of thing. All right, I'm going to kill my video feed. Okay, I have the video, I have the chat up, but if anybody's here. All right, I'm going to start this around. All right, so for day 3, what we're going to be talking about today, and it's going to sound a little bit weird, but we're going to be talking a little bit about how the internet works. So one of the common things to do now with certain bioinformatic tools is to make them available through some kind of an API, especially if it's something that somebody's going to want to call from a program so that they can call it and get back data. We're going to review the specs for our rock, paper, scissors, lizard, Spock project, which is just an extension on our current project. We should be able to implement that fairly easily because we kind of knew we were going to be doing that. And we kind of knew that we should build it into some data structures. So we're going to do some design planning on our project. We'll split into teams like before. I think we're missing a few people today. We're going to do some updates and build out a container. And then we're going to start creating packages and project. We're going to start creating packages. And we'll set a version 2.0, which will do rock, paper, scissors, lizard, Spock. And I'll show a little bit about how, I'll kind of give people a little bit of an introduction to the Python Fast API package. Anybody here ever heard of that one? So Python Fast API is how you have kind of you can make it do web pages for very simple websites, but typically Fast API, you're setting it up so that some program can contact your URL and get back some kind of data. All right, so quick introduction here. Anybody here ever heard of a REST API? Okay, I see 2 people. It looks like Lucas also maybe. Yeah. Anybody here know what a REST API is? What kind of defines its features, anything like that? REST APIs are things that are generally accessed via a URL. And they don't typically require much more than beyond knowing the URL, and typically you interact with them through HTTP requests. Anybody here know what an HTTP request actually looks like? Okay, so nobody here's actually seen kind of a raw HTTP request before. That's kind of the fundamentals of how the World Wide Web works. So it's actually good to know that because it's how you will ultimately interact with a lot of resources online, even if you don't realize it's how you're doing it. All right, so certain commands and certain HTTP requests have 2 parts. You'll notice that it always starts off with a verb. And in this case, the verb is get, but the verb is not always get. There's 4 kind of official verbs, and those verbs are get, post, put, and I forget the 4th one. I think the 4th one might be drop or remove. I forget the exact one, but I think I have it later. But there's basically 4 official verbs in HTTP. So after the verb, you have the URL, but you have the URL after the domain name. So the domain name is actually not part of the request, is not part of the first line. And so what you see here is you have your verb, you have basically your noun, you have your modifiers, and then the last part is the protocol version. That's the first part of an HTTP request. Following that, you have your request headers, and you'll always have a host on there. That's the domain part of your URL. And then you'll have additional information. So typically, if you're through a web browser, it's going to have your user agent, which is identifying what web browser you're using, what kind of data you'll accept back, what kind of language you're in, what kind of encoding, what kind of characters your computer supports, how long to keep the connection alive, and if it should keep the connection alive at all. Some requests have 3 parts, and you'll notice that already we have the so we have the same first line, which is now a different verb of post. We have we still have the URL after the domain, and we still have the protocol. We still have all the same headers, but now there's an additional part down here that's a lot more freeform, and this is called the payload or the message body. So basically, the 2-parters only let you send a request. The 3-parters let you send a request plus some kind of data. A good response will always have 3 parts. So you'll get back a status line. Anybody here know what it means when a web page says 404? Yeah. When your browser says 404, it means page not found. So 404 is actually the status code for the resource not found. That's the HTTP return code for when you're actually getting a response saying I don't have that page. So the response will start with the protocol. It'll have the status code, which 200 just means everything's fine. I'm sending you back a page. And then a code description. You'll get headers and response. And sometimes these headers are going to contain things like cookies. So basically ways to identify your session. And then finally, you'll get the body. So a good response will always have a body. If you get a response of 404, you may not get a body with it because 404 is just saying it's not here, so there's nothing to send. So this is what REST is built upon. REST stands for representational state transfer, which doesn't actually mean a whole lot. The important thing to remember about REST, it's designed to work basically over any network. So the nice thing is because it's just HTTP requests, pretty much every network allows it because that's your standard worldwide web traffic. That's what you need to Google. That's what you need to use Facebook and all the other things. Follows a typical client server paradigm. So you're reaching out to a server. In other words, this isn't something completely decentralized like a blockchain. This is, very clear client server, centralized, all that good stuff. And in this case, you're using basically an HTTP request to ask for data or to post data. So REST should be as stateless as possible. When I say stateless, what I mean is it shouldn't matter what your last request was for your next request. Now, obviously, there's some caveats to that, such as if your last request changed the database, then your next request pulls whatever you change from the database, then you're going to see obviously a response that is dependent on that. But it shouldn't be stateful, as in the server should not have to track what your previous requests were beyond just making its routine database changes in response to requests. The other thing that is also important for this is it means that you shouldn't have to do one request to authenticate and then another request after you authenticate that's dependent on that authentication. So the authentication typically has to be handled per request, which usually means you're going to be using some kind of an API token or an API key or something like that. But you're going to have some kind of way, you have to identify yourself on each request. So client will make a request. You'll notice here, so you have your protocol, you have your domain, just like before. After that, though, this is all going to typically be programmatic, or a lot of the stuff after that's going to be programmatic, which is to say the program is going to be going in there and interpreting these. So for example, results/39 might be the endpoint, but more than likely, this is actually going to be taken in by the program. And the program is going to be saying that somebody's looking up some kind of lab data. This is the server, is lab data server. And what they want is They want something from the results, and they want result number 39, whatever that might happen to be.
If you want to put a transfer to unit cross, if you get login for record unit cross, you don't have unit cross. So, or the something P06001. So they said that it's gonna speak to our record for
Yeah, exactly. So a lot of sites where you're putting in a request for information, now a lot of sites just, it doesn't even have a bunch of static web pages. It just looks up what you're requesting and it generates the page on the fly, or at least it generates the data for it on the fly. It might have kind of an existing template. And then the server is going to take the appropriate action for when you're asking for presumably what's result number 39. Typically, the data is going to come back in either XML or JSON format. Anybody here ever been on like a really slow cell phone connection, like, you know, when you're in certain parts of the LA Metro, and you notice that you're on a web page, you make a request for a web page and it kind of like it loads and you just have kind of a blank page with sort of empty spaces where stuff goes. And then you start slowly seeing, okay, this thing pops up and then this thing pops up and this thing pops up. So that's because the new way of making a lot of web pages are what they call asynchronous or asynchronous JavaScript or AJAX. And the idea behind that is you can load a page faster if you make one request to get kind of the framework for the page, and also the information on what other data to request to fill it in. And then you make an additional set of requests. And usually you'll make a bunch of these requests in parallel, where you're basically requesting all that stuff to fill it in. And what you're seeing as it pops up is it's actually populating it as the data come back in. It turns out that loads a lot faster, and because a lot of times even those requests are going to completely different servers. The other thing that's also nice about that is if you just want the raw data, a lot of times you can figure out what those requests are. And if you put in just that request for the straight data, you'll wind up getting something back that's like JSON format, so easy to load in a program. Okay, basic data operations. So anybody ever here heard of CRUD databases? It turns out there's really only a few things you can actually do with data. And you can basically boil it down to 4 operations. So CRUD is what they call, is the database paradigm. It stands for create, which is make a new data entry. Read, which is return you the value for the data entry. Update, which is changing the value for the data entry. Or delete, which is removing the data entry. And that basically encompasses the entire life cycle of any individual component of data. At some point it's created, at some point it's potentially going to be read, although maybe not. At some point it may or may not be updated. And then at some point it's going to be deleted, or, you know, maybe it'll be kept forever. You compare this to HTTP request verbs. So this is how I mentioned there's 4 verbs. There's get, which is basically equivalent to read. There's post, which is very similar to create. There's put, which is very similar to update, and then there's delete, which is pretty much self-explanatory. Although whoever actually wrote the interface gets to decide how those verbs are interpreted, but generally there's some consensus around these.
In practice, most of the cases are gonna get some post for put and delete are very rare.
Put and delete are actually fairly rare, in part because in part because it's a little bit harder to get those requests working on some browsers, but also just for simplicity's sake, people will typically use a post request to both create and update data. And people will use a get request to read. And then for the delete operation, that may either be a post request where the data being posted is an instruction to delete something, or it may be a get request where the get request actually contains the instructions to delete something. But yeah, so put and delete are actually fairly rare. If you ever do find yourself designing a server, test those commands, because I've actually found some servers where those commands are active in the sort of in the default functionality, and the creator didn't realize it. So you could actually go in. So they basically have functional delete commands that they didn't know about. So if you ever actually do design a REST API or some kind of a server, actually check all 4 standard commands to make sure that the ones the ones that are active are the ones you expect are active, and the ones that are not the ones that you don't expect to be active are not actually active. All right, and then there's the Python decorator. This is something to start learning as you get much more used to working in Python. So anybody here looked over somebody else's code and seen something weird starting with an @ symbol before like a function declaration or before an object declaration? You seen that?
Yeah.
Yeah. As you get more and more into coding in Python, you'll see more and more of those things. So this is a decorator. I remember when I first encountered one in somebody's code, I was basically, what the F is this? This isn't part of a function. Like, I don't know what the hell this is doing. So a decorator basically is almost like a wrapper for a function. And what it does when it wraps a function or an object creation is it's basically saying take whatever's output from this and do something else with it. And sometimes they can even take arguments. So for example, this @app.get. So if app is your REST API that you're building, and if you have this .get here, so this is actually saying if somebody makes a GET request on the app, and this looks a lot like it's an endpoint. So if they make a request to rockpaperscissors.com/RPS, and this is basically saying that what the response is going to be, and the response is going to be an HTML response. And now we have this function, this is what it's modifying, and the function here is send RPS play page. So basically what it's saying is if somebody goes to RPS, they want to play rock, paper, scissors. All right, so rock, paper, scissors, lizard, Spock. It's basically rock, paper, scissors, but now with 5 options. You still follow the same set of rules, which is to say, now instead of one thing, instead of each choice beating one thing and being beaten by one thing, each choice beats 2 things and is beaten by 2 things. And in addition to that, just like before, each choice will only get a tie against itself. So how are the new rules going to affect our code? When I said that we're going to do this yesterday, did we decide to focus on a data structure that makes it easy to extend the game? Yeah. In fact, there's weird ass versions of rock, paper, scissors that have like that have a pretty insane number of options. I think I've seen it where there's like 19 options or something like that. We're not going to do anything like that though. So yeah, in this case, by having been fairly generalized and having our game pretty much defined by a data structure, that means it's very easy to just swap out that data structure, extend that data structure to change how the game is played. Other questions? How can we run this through a browser? And this part I won't have us coding today probably because that's a lot of very new stuff for people who are probably already getting a lot of new stuff. So you guys have a link to the example page. And if you check out the example page, you can see, I think in the previous class, where I ended up making that one kind of the repo for where we have the web API. If somebody wants to check that really quick, if you see the fall 2022, do you see something in there called app or something like that? Or web app, or I forget exactly what.
Like one of the branches?
It's not one of the branches. So if you go to issues, you'll see that there's a couple repos linked in there.
Right, yeah, so in the fall 2022 and 5. That's what it's this thing called web app.
Okay, yeah, web app. So web app is the one that has it. So for that one, for the web app, I won't actually have people coding that, but I am going to walk through how to do it just so you can see that this exists and it's not actually that hard to do. So if we were running this through a web browser, how would we get the player's throw? if you're running this through a web browser, so basically you're now interacting with your user through basically like Chrome or whatever. They're going to access the game by pulling up a URL. How would you get what they're throwing? Yeah, three buttons or 5 buttons. They'd probably be like the sort of radio buttons where you can only have one press at a time, not like checkboxes. So yeah, that's how we would probably do it. So how would the player start playing the game? Would that maybe come in as a GET request? I think that would probably come in as a GET request. How would we get the throw back from the player? What kind of request would that probably come in as? That would probably come in as a post. So probably would be a post request with maybe even just a number in it of just 1, 2, 3, 4, or 5 if it's rock, paper, scissors, lizard, Spock. How do we get the computer's throw? The answer is what you think it is. The answer to this is what? Nope. What?
It just went to cut on this out.
The exact same way we've been getting it already, because we don't need to put an outside request to get the computer's throw. The computer's throw is still just the randomizer function. All right, and what are we going to need in our environment? We'll need some kind of web framework, which is going to be Fast API. All right, so let's build out a Docker container that can play this game. So who feels like they're brave enough to build out? And I guess we'll split into 2 groups today, just to make things easy. Who feels? Oh yeah, actually we have 2. Yeah, so we have basically this 4, and we have the 4 sort of towards the back. So who feels like they want to learn how to make a Docker container? Who feels like they want to make a Docker file today? Okay. And I'll obviously be around the room so I can help you kind of walk through that. And who feels like they want to try building out rock, paper, scissors, lizard, Spock? I guess that'll be you. So, okay. Keep in mind that I did make some minor updates to the repo yesterday, so definitely pull down a fresh copy. But I think we can get cracking on that. And actually, let's see what time it is. Does anybody know if somebody? Oh, yeah. Oh, okay. Does anybody know of anybody who's going to be here a little bit later today? Oh, okay. Okay, well, if Alex shows up and I forget, just remind me to pull this up. But before we do that, I'm going to do student evals. Oh, okay. I actually have an email from Alex saying he's not going to be here, so.
Yeah.
Show us the slide that shows like what lizard needs and what Spock needs.
Yeah, of course.
I'd love to see that. Yes.
I feel like I'm not there, but I might want to.
Yeah, yeah.
Here you go.
Yeah, what are
He's gonna.
oh, okay, yeah, we just have to like build the image for that. Well, like makes it an image, yeah, I think it's actually all right now. Yeah, so you run like you build the image from the Docker file, and then that's sort of like all the packages and things that you need to run, and then the container.
Right. I'm gonna put that up here really quick, and I'm actually gonna leave the room for about 5 minutes so that everybody can do their course evals and say that I wasn't in the room when it happened. So I'll be back here at like 9:45, but in the meantime, everybody can do the course eval.
So basically,
Why did they go?
okay, so rock, scissors, and wood, correct? Okay. Paper, beads. Oh, yeah, the scissors. Yeah. The top. Yes, well, everybody will connect. No. I don't. Oh, this computer. So it just returns like a single letter, and based on that, it then yes, it just says, okay, so this function is for. You haven't created the. No, I think the one basically. It just says you have that. Yeah. So you create something. Yeah. So then like. You can say. Internal. I can go to that folder. Everyone wants us to push this. You break your phone. Yeah, general that. Yeah, so you just go to the terminal. And the command to build is Docker build -t, and then you give it a name. -t is so I think it sort of deletes it after this create so this around. With you just your the Docker file. Yeah. You can give it a directory of the Docker file, but usually like you just give it dot, which is a directory -t and then the name rps space dot. That should go. So this is moving it and then actually what -t does. I just know that it does. We talked about it. Yeah. The -it, like when you're. Yeah, the -it makes it like interactive. Oh, like is it like return things to determine? Yeah. The I keeps it open. Oh yeah. It does. Yeah. So we're in the -t is -t is the intact, yeah. And then -i. I think -i is what we use for it. Yeah, it automatically will just. When but there was nothing else, we've seen the size of the like it installs it basically to make its own complicated. Like it's like a virtual machine. So like everything like it's like a fresh installer. You can do like forward.
Which is the code after this.
So Yeah, so it's just gonna let Michael know, like, you know, okay, someone had an idea that we want, so Docker based those things, it's just like a formal plus. There's also version this year, example for RPLs that was Docker create to me. It's just
so maybe you could like create a container and give it like some
especially if
memory or something.
a lot of meaning, like about is sometimes you can watch about other things. You know, when you go to this version of me,
Right.
only he can. So this is just letting you know the ready for here. So it's not very, yeah, like people.
The image is kind of like, I'm pretty sure it's just like all the files, like all the package files, like Python install.
But if I run it like on my computer, it's all this. I don't know where either.
The next.
Yeah, it's like, it like makes a space in storage for the image. And then when you run the image or like create a container, then it like sort of mounts that image to like some virtual machine with like some
The user has like on the other side of the
Yeah.
The Docker.
Yeah. Yeah. But like images can be like
So
shared between computers and stuff.
Well,
Like there's like a
Day,
Docker file.
let's say,
Bunch of different
you're
stuff.
having rock, paper, scissors,
Just like for like a bunch of different environments.
create.
Yeah. Yeah. Like for like if you're trying to run an line of there's like a list.
You normally run. You just or just.
I usually have like the virtual space. Oh, yes, yeah. But I think you can get a like they have a it's called something else though, like app tainer. Yeah. Yeah. Like it's basically like you can create a conda environment and an image and then run as a container and like it is sometimes better, but yeah, you just make a conda environment. It's like the same thing. Yeah.
Oh, no. Oh, really? Oh, right. Oh, okay. Oh, you guys know.
So it's like, well. So the thing was like, I guess, I think that like a lot of what comes with like learning this stuff is like practical experience. It's not just like classroom.
Yeah.
Go out and build projects. And once you do that,
Yeah.
you really learn a lot of this stuff. And so even though I was a biology major, I was a computer science minor.
Oh,
And
okay.
I did a lot of bioinformatics research. And I had to like,
Okay.
I literally just run like a project so I have to get published.
Yeah.
But I'm learning new stuff, a lot of this.
Yeah.
thanks to Michael, but I got a lot of experience like with getting.
You use GitHub?
Yeah,
Okay.
that's basically what I was doing. I like, computer science, like, they don't teach you. They just teach you all the conceptual stuff. Like,
Yeah.
how to do it. You know, but they have a lot of, like, there's a practical aspect. that
Yeah.
It's
Or
actually,
just be stranded and have to figure it out.
yeah,
Yeah.
yeah. Is it just Docker build? Like, actually, yeah. There's
Actually, and then like the name of the container or the image. So like, yes.
Everybody get this, everybody got that?
Just
Once you're actually.
to tell it what's
Yeah.
No, it's
Oh,
Sorry.
let me pop that back up again.
Did you push?
All right, actually, just come over here and grab it off my computer.
Yeah.
Yeah.
I started.
So if you're getting there.
But I didn't. I didn't.
Just your own Docker.
Oh, yeah.
Oh,
I think it has to be all of
We figured it out and created the game and then we pushed it to the range and I guess we can do it on a.
Okay, did you actually play the game?
Yeah, yeah.
Oh, okay,
Just type Docker engineers for Docker.
okay, yeah, try.
Okay, you should be good.
Yeah, okay.
so pull request finalized.
It allows us to let him know, ask him to.
Yeah. So officially, you're actually all owner of the repo, so I need you to put a pull request,
I see,
But-
okay.
but a pull request along with the fact that it's just basically saying, I want this pull domain. It's also, if you actually fill in like, if you fill the details of it.
You should just be able to just do that, like, you know, the Docker.
The link wasn't.
don't need to specify
but,
that.
class-
Okay, because it looks for it. I got it.
It just has to be called Docker.
I see, I see.
Yeah, I put it.
Oh, just come over here, grab it.
Thanks.
My phone wasn't recognizing the QR code.
So you have to log in. Usually, I think I have like a SSH key that just automatically. Whenever I come to the server, but- I don't know if that's this problem. Because it seems like you're not.
Do you know Kristen? Or you just?
I think I've seen her.
Yeah.
Oh, she was doing great for the-
Oh, okay. Like yesterday, I was in practice in class.
Yeah.
I was like barely, my brain was. One thing.
I think that's the number one reason I heard of MDs who go primarily the research route,
Yeah,
was they were like, I like the hours better. I get to sleep at night.
yeah. It's really hard, like even though I slept overnight, it's like I'm constantly getting woken up by pages. It's not good sleep,
Yep.
It's like to get to your rest sleep, I need 3 hours, uninterrupted.
So the dash R is moves a container.
And that actually just makes it.
Yeah.
You can, but you try it all.
Pretty bad. No,
Oh, okay. Yeah.
I mean, but like I graduated in 2008.
Oh,
Yeah,
yeah. That's
you know, the med school residency fellowship.
Yeah.
Where'd you go to med school, by the way?
I went to, when did I go?
Where?
I went to Columbia.
Oh, okay.
Yeah.
Oh,
Yeah,
Oh,
So I don't even know if they even had. I don't think Columbia's a very.
Yeah, you can like direct install.
Yeah, I mean.
So-
Yeah.
Yeah.
So I'm going to show another way of doing Git operations, but in this case, so I already have my GitHub account set up on with my pie chart. So I'm going to do an update on the project. And everything's already up to date. I'm going to go to the Git options down here. And I see day 3 Docker. What did you call your RPSLS branch?
Yeah.
RPS.
Oh, there it is. Okay.
Is it gonna be overwritten?
Right now, I didn't give it this much.
I see. So one thing that sometimes helps is it looks like you probably committed your all right.
So we committed it, we created it for.
Yeah, basically the only difference between what you had and what I had, because I keep mine pretty basic. You didn't have an interpreter defined, whereas or you had a different interpreter defined, whereas that's an easy fix on my part. Okay, so I've downloaded RPSLS. Oh yeah, this projector has crappy. Okay, that looks to work. It looks like it works to me. So yeah, you can actually handle an entire merger. You can handle an entire pull request through your pie chart. Okay, that also means that the code has been updated, so you guys should pull down a code update. Generally good to keep your IDE stuff off of the Git tracking, because as you saw here, it was causing a little bit of a conflict. In this case, since we're all basically using very simple IDE settings, it's not going to mess with too much. The worst thing that might happen is you might have to just reset what your Python interpreter is. But that takes like one click, or takes 2 clicks actually. But what you should notice when you pull down is your current changes, like the Docker file you created. that should still be left intact unless you do some kind of very weird update. All right, if they're doing that, I'm going to deal with the previous instructor leaving junk around here.
Exactly. Yeah.
Yeah.
Yeah. The MPHD route. They add-
We were gonna get him.
This route is. I am in the village direct. Years ago.
The track itself is like mostly filed, but then all the surrounding areas, so like nobody comes in like really good. Like all the way. Because I think it's like the tracks like.
Yeah, that's true. I guess if you do your PhD, you get med school tuition for free, but now I get. Like, training, it's not a terrible. Salaries, I thought. So, but you do have, I do have kind of more responsibilities. While I'm doing it, but and then it also should only be like 2 years. PhD. So, I don't on every single thing I want to do. There's the political stuff.
Yeah. Yeah.
Like every single thing I want to do, so I have to like resubmit the IRB, like this.
Yeah.
Like, yeah, I'll get to ask for permission for that data set. I just can't ever just like learn.
How's it going?
Did you get that in? You're pushing it down there.
Okay.
Yeah.
Okay, perfect. It has not showed up on my email yet. I was just checking.
Yeah,
Yeah.
stuff that.
So yeah.
Yeah, kind of. It's rock, paper, scissors, lizard, Spock.
Super.
I mean, also, we're interested in making things more. Stuff,
Yeah.
like Alex is very like technical.
Yes.
Very applied.
Yes.
So I'm looking more like. A3 Docker.
Yeah, no, he's like. Does a lot of like really, a lot of things that are very applicable to actual clinical practice. And everybody in his department is like also this for the doctor.
Yeah.
Like I'll start to explain things to them and they're like, "Oh, yeah." Yeah.
Every time I.
What did he do?
I think he was saying he was just watching one of the YouTube
Who's trying to learn through YouTube videos? Oh, okay, which one? Who? Oh, okay, I don't know that one.
Yeah, he's a year below.
Okay, let's see if there's actually a really good instructor on Udemy whose classes tend to be very affordable if you're like you can get it for usually $20 if you catch a sale.
Yeah, you were telling me, right, for machine learning?
Yeah, so the guy covers like he covers like an intro to Python, like a boot camp. Like
Okay.
I think it's a 24-hour long Python boot camp.
In Coursera?
Udemy.
Yeah.
It's like one very specific instructor on there named Jose Portilla. A guy named Jose Portilla.
Okay.
He has a really good Udemy. Yeah, he's got a really good Udemy series. All right, so we have our from statement. So we've defined our base image. You're using a Python 3.11 image, which is a very good choice. We're doing apt update. Is that line actually necessary though?
Maybe not.
Yeah. Because we're not actually updating anything through apt here, we're updating stuff, we're downloading stuff through pip. All right, we have our requirements.txt. But there's nothing in it, which, okay, that's actually what I would expect because we're using like bog standard Python. You will see that change though in the version that uses the web app because that has to actually pull down a few different packages that are required for setting up a web app. But this is actually the right move because anything that is in requirements will be copied into opt. The only thing I might do differently is I might move requirements into opt/RPS. Because in theory, if you have multiple Python packages, they might have, if you have multiple Python apps going in here, they're going to start having requirements trip over each other. I'm not too worried about that right now because that's not going to affect what we're doing. But, you know, if this was actually being packaged as like software to be distributed, I'd probably tell you to make that change. It's also not a hard change to make. All right, install requirements, make dir RPS. Yep, this looks like it should work. And then we have our command to start running, which is there. All right, so I'm going to show you something really cool that PyCharm can do. So I lost my interpreter again because people's .idea file is making it into the repo. Again, generally, I try and keep those out of repos because it'll cause issues like this with different people using PyCharm, but here it's not too big of an issue. I'm going to add a new interpreter on Docker. And it seems to already know that the context folder is the current folder. You can barely see it because the projector kind of has a light bulb right now that sucks. But the context folder is dot, which means it's the current working folder. The Docker file is the Docker file. That's just default Docker behavior. I'm going to call the image RPS. And watch this, it's actually going to try and build the image. Give me a second, it helps if I have Docker running first. All right, so one thing you'll notice if you are running PyCharm creates its own container, which is kind of its Docker helper. So I'm going to get rid of that screen. All right, now that Docker's running, I'm going to try that again. Add new interpreter on Docker. Tagged RPS. The other thing I like about Docker is it just knows if you don't have an image to pull the image.
What's the user rack about?
So inside the Docker, it's running as root. That's one of the reasons why Hoffman doesn't like supporting Docker. Is inside your container, you're running as root, and that actually, and because of the way Docker's configured, it's not designed to really limit your privileges on the host machine. So when it creates a file, it'll actually create a file with user 0, which basically means it can create files on the host machine as root, which can do some nasty stuff if you're not careful. That's one of the big differences between Docker and Singularity, is Singularity can't do that, so Singularity has better safety profile. All right, so it's now connecting into the Docker. And you can see here that my interpreter is now the interpreter inside of the RPS container. Let me give it a minute to get this done. Actually, I could probably just get this working. All right, so we're going to try and run main, but this time we're running it from within the Docker container. Let's see if everything plays nice. Right. For reasons I don't understand, it's taking a little while to update the info on the Python interpreter, but it's should be doing its thing. There we go. Okay, so this looks like it's playing rock, paper, scissors. Okay, so that's merged in. Check out the main branch again. All right, so I pulled down the new one. Again, this is why it's a good idea to tell Git to ignore your .idea file, is it'll start causing conflicts with other people's IDEs. But while that's updating, so we have our Docker file and an RPS. So you can see here that even though those files were worked on independently, Git is smart enough to know that those two files were both updated, and it's merging them together in the update. Okay, and it looks like it's updated the interpreter. Okay, so what we have here is this is, you'll notice my interpreter is now set to inside the Docker. So we have Dockerized this app. You could basically now share this code with anybody. If they build the container kind of the standard way, they'll be able to run it on any system. Obviously, this one doesn't really care much which system you're on, but if you have some built-in dependencies like a Linux dependent aligner, which is a very common thing in bioinformatics, it would work fine on a Windows system because it all runs in Docker. All right, for the last thing, I'm going to go over. Okay, so this entire bunch of code is 47 lines long, and that's counting the fact that I have, white spaces in it. Okay, so here you see that I'm doing quite a bit more importing. I've imported fast API templating, UVicorn, and RPS support like before. So these three are obviously the things that I want for making a web app. The UVicorn is, that's basically like a very general web framework that fast API sort of lives on top of. I have a new folder here called HTML. That's my HTML template folder. And you notice here I have my I have my RPS rules and my RPSLS rules. The default game is RPS, so just if somebody doesn't select the game, it's RPS. And then here I've declared my app, which is a fast API, which is basically just declaring it a fast API app. And I have my templates file, which is here. And you see all these decorators. If you remember the pattern I showed before, these decorators are just declaring endpoints for the API. So this is not the only thing you can do with decorators. There's actually a lot of very cool stuff you can do with decorators, including if you look at any of my code, you'll see a lot of decorators in objects that are declaring things like declaring properties and class methods. Those are kind of the two that people tend to get started with first. So properties are things in objects that behave like attributes, but are actually methods. But you treat them a lot like attributes. And you interact with them like they're attributes. Class methods are cool because it's basically a creator. It's a special kind of creator for the object, which is just if I want to function within the object class that instantiates a class based on a specific type of incoming data. Like maybe I have a standard data list format that'll come in and instantiate the object. That's an easy way to do it rather than having to kind of do it a more difficult way or having to sort of declare it on the fly every time. So really quickly, we'll go over how the structure of this project is a little bit different. So there's an HTML folder here. And you notice we have play and result. So play, very short HTML page. Anybody here already familiar with how to write and read HTML? A little bit. Okay, yeah. HTML is based on tags, so you're doing a lot of just declaring stuff and giving it properties. But basically we have, we have our headers, we have our title. Also, if you notice, we have this value here that's enclosed in double braces. So this is actually because Python has a templating engine called Jinja, or actually Jinja 2. And Jinja 2 knows how to fill these in with the appropriate values. So this will actually get filled in with what game they're playing, whether it's RPS or RPSLS. We have our form action, which here it's going to be, this is basically saying where it's submitting to, and in this case, it's submitting to whatever the game is that they're playing, so RPS or RPSLS. Its method is it's posting, so it's posting data there. And here it's saying, here it's iterating over the possible throws, and it's just creating a radial list of possible throws. So that's actually the way that we talked about interacting with it before. And you can see here that even though this isn't Python, this is basically declaring a loop. And then we have a button to submit. And that's basically the entire page. We have our result page. And the result page is what it returns when somebody submits a throw. And so here we're saying, so this is just going to be called statically result. And here we're saying this is the outcome and what the computer selected. And then we have a button down here to play again, which is actually, or not a button, but a link to play again, which will just take them back to the, game, either RPS or RPSLS. So again, if you look up what this is doing, this is using something called Jinja 2. Here, the main function is actually very, very stripped down. So here for the win function, we're just basically loading our table of wins. We have our result in our computer throw, which are coming back from this function. And we're going to print the result out if somebody's playing not as a web app. All right, so for this web app, we're saying if somebody just goes to the default page, so they just basically go to they go to whatever IP and port this is on, which I forget what number I use, but I'll figure that in a bit. Actually, I can tell you right now. This is running on port 44444. So if you run your web browser to the localhost :44444, that would actually take you to this game if this Docker was running. So here we're declaring an endpoint of, if they go to /, then what they're going to is the default game. If they go to RPS, then they're going explicitly to rock, paper, scissors. And what you see here is this gets an HTML response. And what we're declaring here is they're going to play.html. The request is whatever the request happens to be. But more importantly, the ID is going to be identified as RPS. The game is rock, paper, scissors. And the throws is going through the rpswins.keys. So rock, paper, scissors.keys. If they go to RPSLS, we see almost the same thing here, but we're actually giving them now slightly different data structure. So we're saying the game is called rock, paper, scissors, lizard, Spock. And now it's RPSLS wins. if they post, so they can either post to RPS or they can post to RPSLS. So you notice here it's the same pages. It's RPS, RPS, RPSLS, RPSLS, just different verbs. So if somebody posts here, then they're basically sending a throw to RPSLS. So it's going to get the computer throw, and it's going to get that just like before. So it's going to call that random computer throw function for RPSLS. The result is going to be just running the feeding this determine outcome function, the RPSLS win matrix table, the computer throw and the player throw. And it's going to return a response here. And it's using templates. So using templates is what lets it automatically fill in those values. It's going to return the result.html. And in this case, it's going to say the ID of the game. That's RPSLS, the outcome, and the computer throw. And then here's the if name equals main, which is actually just saying to run the app. So it's running the app. The host is on the local machine, which is in this case 0000, because that's what Docker calls its internal network. And it's on port 4444. Oh, because when a post request comes in, that basically is going to get an immediate response. But when a GET request comes in, it's going to get an immediate response. But it's actually waiting on a post request. At least that's the way I understand it. Let me see if I can get this up and running here. Here we go. All right, we do the same thing I did before. All right, now you notice it's doing a little bit more stuff because it actually has to install Python packages. All right, and while it's doing its usual update thing, all right, actually, I'm going to show you exactly what. Okay, so This up here is your run configurations. That's where you can set things like command line parameters when it runs, to tell it kind of how to run. So if you go to edit configurations, if you're running in Docker, this tends to be particularly important. So I'm going to expand this out. These are the Docker options it's running with. And the important one is the -P, which is telling it that it's opening up port 4444, and it's exposing it as that same number. If you click on this folder, this actually gives you the option to start making changes. So in this case, you see here that we have, oh, I did the port binding just as a manual command. You can also do the port bindings up here. This is a PyCharm default, so it's by default just mounting this folder in the, it's mounting that folder in the container, but these are the options it's running with. So I'm going to tell it to run. All right, so that 127.0.0.1, that's just the IP address that says my own computer. And this is running as a little web server inside my computer now. So my computer is actually talking to the Docker through a web port. And you notice it went to RPS by default. So if I pick rock and hit submit, it says I lost because computer submitted paper. If I jump over to PyCharm real quick, you can see here where it's actually logging all the incoming requests. So you can see it logged the request of, there was a GET request on just / that returned a redirect, and the redirect it returned was to RPS. It made this, the browser makes that request automatically, but there's no fave icon for this. So, and then we had a post request to RPS, which was me throwing rock. The computer got paper, so it returned a response of me losing. And if I just go to RPSLS, I get the rock, paper, scissors, lizard, spot page, and I can throw a lizard, and it says computer selected rock. So I lost. I can throw rock, and I lost this computer selected spot. I'm not having good luck. But again, if I go back to PyCharm, I can see a trace of all those requests. So yeah, it took less than 44 lines, but it actually turned this whole thing into a web server through a fast API. So the code is up there. You can find it on the web branches if you want, but that is basically how you do one of these things. So definitely, if it's something you get into, feel free to email me for help. I'm always happy to give some advice or at least point you in the right direction. But yeah, I think that's I think that brings us to the end. So if there's at this point, I'll take any questions anybody might have, or if somebody wants to know, like, if somebody has a plan they want to use this type of thing for, and they wonder how it might happen, I can also kind of walk through. I can also kind of game out how to do it. So if anybody has any questions, now's kind of the time for them. Otherwise, everybody gets out early.
We need help with the homework. I would email you a question.
Yeah, of course. Oh, that is something I should say. Collaboratory classes as a rule should only be giving about no more than about 2 hours of homework. So if you hit the hour mark and it looks like you feel like you're probably not going to be able to get it done in about 2 hours. Especially if it's looking like it's going to be more like 4 to 10 hours. Reach out to the instructor. That includes me, but reach out to the instructor for the course and let them know. Collaboratory courses should not be giving more than should never be giving more than 2 hours of homework for a session. So if you do find yourself either looking like you're going to hit that or you actually have hit it, and it looks like you're not going to finish soon, reach out to the instructor, because usually it means either there's something you're not getting or the instructor did not do a good job of gauging their homework. If people took the Python, the first Python class, you probably noticed that there was a real excess of homework there. We're trying to curb that.
Okay.
It's a weird issue that,
That.
yeah, for the Python class, that's a weird issue that crops up with that first Python class when we have newer instructors. I mean, you can kind of imagine it's also hard for the instructor because the instructor is kind of like an experienced Python programmer.
Right.
So they take one look at the problem, it's like, oh, I know how I'd solve this. It would take me 5 minutes. But I know with the previous instructor, I actually walked through with him and he's like, yeah, I could solve this. It takes me 5 minutes. Like, okay, what would you do to solve it? And the response was, I'd use a state machine. It's like, okay, when did you teach state machines?
Yeah.
It's like, you didn't. It's like, and then it's, when do I teach state machines in advanced Python? Hint, I don't.
Yeah.
So it's like, yes, you can solve this in 5 minutes using a technique that these students have not even been like remotely close to being taught yet. So if you do run into excess homework, speak up to the instructor. A lot of times the instructor just didn't quite gauge it about right. You should be getting an email from me either later today or early tomorrow that will have the homework assignment on it. As a general rule, I like to get the homework back if at all possible. Not Sunday night this weekend, obviously, but Sunday night, like by Sunday night next weekend, that's usually when I'll grade. I know, for example, you have clinical responsibilities. Everybody here probably is in a lab or at least has classes. And I think we're also getting very close to exams right now. So if you do run into a situation where you just, for one reason or another, can't get it done by Sunday night, shoot me an email so I know to keep an eye out for it. The other thing is the homework. For the homework assignment, you'll both get the homework assignment and the quiz link from an email address that is not my UCLA email. It's something like weinsteincollaboratoryhomework@gmail.com. That's an email address I keep strictly for homework. And I do that so that there's no risk of like something getting lost in spam or anything. So basically use that address for the homework and only for the homework. If you have regular questions, send them to my UCLA email. Just use that address for the homework, but expect to see something from there probably in the next 24 to 36 hours. So basically by tomorrow night. And like I said, I generally try and get the homework graded the Sunday, not this upcoming Sunday, but the following one is when I usually try and have it graded by. So if you can't get the homework in by then, just give me a heads up so I know to look for it later. All right, so if there's no other questions, everyone's free to go. These repos, they always stay online. I never take them down, so you can always refer back to them if you kind of need a starting point for something.
Oh, could you put the QR code back on? It was kind of truncated last time, so we could
Oh, yeah.
read it.
Oh, I didn't know that was people were having trouble reading it. Let me pull that back on up. All right, that work?
Yeah.
Yep, see you.
Yeah.
You worried about the Unix one?
It's like, I don't know how he solved it. Yeah. I don't know. It worked though.
Oh, okay.
Wasn't sure if it was in that spirit of.
Yeah.
I think solving a Unix problem in a way that the instructor had not intended is in the spirit of Unix, if nothing else. All right, does everybody have the QR code now? All right, I'm gonna kill the presentation.